In lesson 2.2, we're still solving equations, but this time we're going to be solving them using the multiplication principle. So some of the key terminology: the multiplication principle states that for any real numbers a, b, and c, c cannot equal 0 and a equals b is equivalent to a times c equals b times c. In other words, you can multiply both sides of the equal sign by the same number and you maintain equivalency. The multiplicative inverse of 3 is 1/3. Multiplicative inverse means the same thing as reciprocal. The multiplicative identity is 1, since 1 times x equals x. And the coefficient of 8x is 8. Coefficient is just the number part of a term. So now let's look at a couple of these. We won't solve all of them, but we will do a couple. So let's start with the first one, number 5. We have 4 times x equals 28. Well, we want to get x by itself. So there's actually two different ways you can think of this. You can think of this as multiplying by the multiplicative inverse, which of 4 would be 1/4. So if you multiply by 1/4 and you put 4 over 1, the 4's cancel and you're left with simply x on that side. Well, remember, what you do to one side you have to do to the other side, so I would have to multiply the other side by 1/4 as well. And 1/4 of 28 is 7. Now the other way you can think about that problem is 4x equals 28 is, think of it as a multiplication problem. And how do you undo multiplication? Well, division. So if I divided by 4 on both sides, I would achieve the same result. 4 over 4, those cancel and become 1. X equals 7. So dividing by a number and multiplying by its reciprocal achieve the same result. So depending on what the numbers look like, if the numbers are integers, I tend to think of it as division. If the numbers are fractions, then I would probably use the multiplicative inverse, and we'll see some of those. So sometimes they get kind of tricky, like number 7. It's negative y equals 20. Think of the imaginary 1 that's in the front of that y. So then you could divide both sides by negative 1, and you're going to get positive y, because those negative 1's cancel, equals negative 20. So even if you don't see a number, just remember that there is that imaginary 1 in front of the variable. Now here's a variety of different problems, and again we'll just pick a few of these to work through, but you can see some of these are fractions. So some of these I would definitely use the multiplicative inverse to help me solve. So let's look at a couple of these. Let's look at, how about just the first one? We have m divided by 8 equals negative 7. So dividing by 8, you can also think of it as what gets rid of division, or what's the opposite of division, and that's going to be multiplication. So if I multiply both sides by 8, and I'll put that 8 over 1 because then you can see that those really do cancel, then I'm going to get m equals negative 7 times 8 is 56. And you can always double check that. Is 56 divided by 8 negative 7? And that would be no, because I forgot my negative sign. That's a negative 7 times 8. So it's a good thing that I checked. Okay, let's now look at, how about number 16? I'm going to come over here and make it a little bit bigger so it's easier to read. Negative 3/4 r equals 5/8. Well, you can think of it as a multiplication problem, negative 3/4 times r, and you would have to divide, but you're talking about dividing by a fraction. So these are the types of problems that I think it's easier to use the multiplicative inverse. And the number we want to get rid of is always the number that's on the same side as the variable. So I'm going to multiply by the multiplicative inverse of negative 3/4, which would be negative 4/3. So I'm going to have to multiply both sides by negative 4/3. And that's going to give me, well, my 4's and my 3's, and everything cancels, which is what you want to happen. You have a negative times a negative, so that's a positive. So all I have left is r. And then 5/8 times negative 4/3 would be negative 20 over 24, which can be reduced. 4 will go into both of those, so 4 goes in 5 times, so that would be negative 5, and 4 goes into 24 6 times, so negative 5/6. And if you take negative 3/4 times negative 5/6, you should get a positive 5/8. Okay, let's look at 14 is an interesting type of problem. We have negative a over 7 equals 8. Now, they have the negative on the a, but remember we've talked about this before, where you can have the negative on the top or the bottom or floating in the middle. Just don't have it on both. I'm going to prefer, or I prefer to have it on the number. So I'm going to put my negative on the 7. And the reason for that is I'm solving for a. I'm not solving for negative a. I don't want to know what negative a is. I want to know what positive a is. So I haven't changed anything other than the placement of the negative sign. So now it's a divided by negative 7. So let's multiply by negative 7 over 1. Multiply by negative 7. So negative times negative is a positive, so I have just plain old a on the left. And 8 times negative 7, negative 56 on the right.